In this video, we are going to discuss about the major oil and gas equipments used in process plants. Being a piping design engineer, we should have a strong knowledge about these equipments so that it will help you in many other ways in your day-to-day activities, in your project work and your new projects. Let me tell you a couple of benefits that is seriously going to help you. One of the most important benefits that I could see if you possess the knowledge of the equipments is you will be able to visualize the design when you go through the scope of work for any new project. And the second most important benefits that you will get is that you will be able to visualize the magnitude of your design work if you understand the equipment details or if you have a good conceptual knowledge about the equipments. And third most important thing is that you will be able to do the design estimate properly, which is almost equal to the accurate assumed estimate, we could say. But if your understanding about the equipment is wrong, your estimate can go wrong. So these are the three important activities that one should do at the beginning of the project. By having a good understanding about the equipments, you will be able to do it. Other than this, you will also have a lot of other benefits, which some of the benefits that I could see something like there are activities that you supposed to have a good idea about it to which you have to pre-plan it during the detail engineerings. So those kind of activities you will be able to plan much better than others who do not have this knowledge about the equipments. So there are lots of other benefits also that will help you at different points of your different stages of your projects if you possess these knowledges of equipments. So this video is going to give you a conceptual understanding about the major equipments that we are generally using in any oil and gas projects. Why the conceptual understanding is far more important? Because the moment when somebody gets a pump drawing or a vessel drawing in any of the projects, the people, they go in chaos, because the kind of informations and the amount of informations that they have to refer. And most of the important thing is that most of the people do not know about what informations needs to be referred and what are the exact key informations that are required from all these factors which are already in the drawings. So the moment they see the drawings, their mind go in chaos. They will completely go out of control. They will have a lot of fear, a lot of doubts about which are the informations to be checked, which are the informations not to be checked, which to be used and which to be kept on hold. There are many things that goes wrong. That is because most people don't have a conceptual understanding about the equipments and the implication of this details of this equipments that is impacting their piping design. As a piping design engineer, we don't have to design the equipments, but we need to use certain inputs. We need to consider certain inputs for the piping design, for the layout planning, for the plot plan finalizations and everything. So that is when that will help you when you have a good understanding about this conceptual knowledge about the equipments to finalize all of this. So this video is dedicated for those who are interested to understand about this major equipments conceptual details. So without wasting your time, let's get into the video. Oil and gas equipments. Pumps. Pumps are considered to be one of the major equipments in oil and gas plant or in any other petrochemical or refinery process plants. It doesn't matter whichever type of pumps that we use, but the most important thing is that we should understand the pumps conceptually. Generally, when people came to know about the pumps involved in the project, they will end up having a lot of confusions and doubts because the people are not clear about what informations needs to be referred, what are the key informations that they have to consider for their designs, and so. There are so many doubts that arises because of the ignorance. So here we have different types of pumps. I seriously don't want to go to the types of the pump because that will deviate from our intention. As a pump, we should understand it is an equipment that transfer a fluid from one location to another location. Irrespective of the different types of pumps, the only intention of any pump is to transfer a fluid from one location to another location. So basically, If you install a centrifugal pump, if you install a reciprocating pump, if you install any other type of a pump, it will only going to transfer a fluid from one location to another location. So functionally we have to see the suction and discharge. So as a piping design engineer, we should always see that the suction and discharge are primarily addressed, what is the rating, sizing and so on actually. Because if you are going to go with a lot of details, then it will actually won't help you in your design. Look at these pictures. Generally, the schematic of the pump, it consists of a motor, it consists of a pump, it consists of a nozzles, it consists of impellers. But for us, the what is most important thing is that your pump inlet and pump outlet, which is known as a discharge. The one more thing is far more important is the size of the pump, because the size of the pump is going to decide the space that you are going to occupy in your plot plan and layouts. So size of the pump is also very important. So if you have this understanding, so it doesn't matter whether the small pump or a big pump, you will be able to visualize your design accordingly. Say for an example, if you get details from a vendor, something like this, actually you will only have to focus on the overall dimensions and your suction and the discharge nozzle details actually. So this is what very important as a piping design engineer. As long as you don't have this conceptual understanding, then your fear will vary from different types of the pumps. But if you have this in conceptually fixed in your mind, actually, even if you have a multiple types of the pumps, even if you come across different vendors or different configurations, you will not have any doubt about what information that you have to refer. Now let's go to the next equipment. It's heat exchanger. Heat exchanger is considered to be one of the major equipment. So this is how the heat exchanger generally looks like. This is a sectional drawings. The purpose of the heat exchanger is to transfer a heat from one medium to another medium. Here I have shown the shell type heat exchanger. There are air cooler, fin fan exchangers as well. There are plate exchangers. There are different types of exchangers. But intentionally, when you understand the functions of the heat exchanger, is to transfer a liquid, the heat from one liquid, or we can say one medium to the another medium. So if you look at this picture, I will tell you in much more detailed picture actually. If you look at this picture, you will be able to see there are two streams available. See here, there is a liquid in, and this liquid in will go through the tubes and it will come out through the liquid out. Okay, and there is another stream which is the cell shade actually. It will go in over here and it will run across the tubes and the fluid will come out. So there are two different fluids that is flowing in different directions. So the heat or maybe the coolness that is transferred from one liquid to another based on the temperature differences, that happens in the heat exchanger. So as long as you have this understanding strongly, you will be able to make up all the designs irrespective of whichever exchanger it is actually. So if you look at the purpose of this heat exchanger in any process plants, this is how it would looks like. Here we have a heat exchanger over here, we have a heat exchanger over here, we have a heat exchanger over here. So if you look at, for a simple example, this is a refrigerant package. Okay, refrigerant that helps you to transfer the liquid which is a low in temperature. So if it goes to the heat exchanger, so the other fluid which is at the which is at the high temperature gets cooled down. So basically this kettle exchanger will helps you in transferring the coolness from the refrigerant to the another the fluid which is at the high temperature. Likewise, there are temperatures which the heat exchangers which helps you to increase the temperature, reduce the temperature. Look at over here, reboiler. Okay, so reboiler circulates the fluid from the vessel wherein the steams are passed. Okay, so generally the steam temperature is much higher than the other temperature, so the reboiler circulates the hydrocarbon will get heated. So this is how the heat exchanger works. It doesn't matter which types of heat exchanger, all the heat exchanger performs the same function. You only need to understand the conceptual understanding about, so that you will be able to visualize it. The next one is drums. Drums are philosophically, it looks like this, which is used in various services, various locations. It could be horizontal or it could be vertical. Basically, it is used for an intermediate collection tanks or knockout drums that will help you to collect and transfer the fluids or some things. So you will find the drums which will have a small pumps, because that will circulate the liquids from the drums to the other fluids. Basically, it will have a simple configuration of a liquid in and liquid out and the vapor out, and the maintenance access and level instruments. So I don't want to get into the detailed design because I want you to give the conceptual understanding. So drums are an equipment that will have a liquid in and liquid out, and as well as it will have the vapor out and the maintenance access. So as long as you have this understanding, you will be able to visualize, okay, with respect to the size of the drums, you will be able to immediately visualize this is how it would look like, so that you can consider the actual size parameters and height parameters, everything in your design. Fine. So now let's get into the process side. See, if you look at the P&ID, let me show you this example over here. See, this is the equipment which is used as a drums in the P&ID. Fine. So from here, the services from the air coolers that goes to the equipments, and from here it is again pumped to the major vessel, the major pressure vessels. We can call it as a distillation columns or any other columns. So drums are used as an intermediate storage to transfer a fluid from any other major equipment to an other major equipments. So this is how we need to have a conceptual understanding. Now let's go to the tanks. Tanks are basically storage tanks. There are different types of storage tanks are there, but predominantly we should understand about the storage tanks. Is a tank that is used for storing most hazardous, flammable and hydrocarbon and most toxic chemicals and products. So it will have its own requirements. It will have an inlet nozzle, outlet nozzle. It will have the level transmitters. It will have a pressure gauge. See, look at over here actually. So you have the inlet line, you have an outlet line. So any equipment, you will conceptually have an inlet line, an outlet line and a man ways, because these are the primary things that are required for any equipment. Then with respect to the capacity and everything, it will vary in sizes. Every equipment will have a drain as well as a tanks, and you have a PT, pressure transmitter, to always monitor the tank pressure, PG to see the pressure over the tank, and there are blanketing gases, there are PSPs actually. These are standard items. So if you have this conceptual understanding very clearly, if you go to spend time to understand these things actually, you will typically apply this in every project. You don't have to worry about your knowledge actually. So because this is going to be typical, it is not varying from project to project. It will vary a little bit, not entirely. That is what my intention is. So the very important thing is that you need to have a conceptual understanding. The moment you get a tank in your project, don't be fearful, don't be doubtful about it. You just go to the details and you will be able to understand that most of the things are matching what we are discussing over here. Okay. Now let's go to the compressors. Compressors are one of the key equipment which is considered to be the heart of any process plants. So there are different types of compressors, and the purpose of the compressors are to compress the gas from the low pressure to the high pressure, so that it will be able to used for the another type of a process which requires the high pressure. Fine. So that is the intention of the compressor. There are different types of compressors, but one of the important thing about compressors is that based on the types of compressors, there will be the different piping requirements will be there. But however, these requirements are addressed in the P&ID. Okay, you will have to follow the P&ID. You will have to find the nozzles of the compressors. You will have to find the interconnections actually. So all these things can be followed with respect to the P&ID. But when it comes to the location of the compressors, then you will have to do some work. Okay, so that work that will you will be coordinating with the respective technical safety engineer in order to locate it. But as far as compressors are concerned, you will just have to see that how the function of the compressor is to compress the fluid. Look for an example. From here, there is an inlet line that goes to the compressor, and it gets compressed, and it then goes to the aftercooler. Okay, so the moment you see the compressor, you don't have to panic. Compressor is a equipment that compresses a liquid from low to the high pressure so that it can be used for other services actually. So even here you are going to use the simple piping, but only thing is that piping requirement will be based on the pressure and temperature that the compressor is going to be handling. So this is the conceptual understanding you need to have actually. Now let's go to the turbine. Turbine is also more or less a similar equipment which are equal to the compressors, but here the purpose of the turbine is to generate the power. At many cases the turbines are coupled with the compressor so that the power generated by the turbine can be used to run the compressors actually. Even here your intention is to understand that the compressor has an inlet and outlet of a piping wherein the services that comes inside the turbine, and it will be used for multiple purposes in order to generate the power, and then the whatever fluid that comes into the turbine that goes out. So you will have a suction, you will have a discharge. Of course, I understand that there are lots of other micro level lines like drain lines and vent lines, and there are PSVs, and those things are available. Thus, that will be identified in the P&ID, and based on which you will be able to do it. But here the one most important thing you have to understand is the compressors and the compressors and turbines are equipments that are purely manufactured by the vendors. So the size of the compressor from one vendor to other vendor varies, and most importantly actually the configuration also varies. So you will not be end up having the typical compressor of same size or same nozzle orientations and everything. Based on the different vendors you will have a different configuration. So what you have to do is that you just have to change your piping accordingly in order to meet the requirements. Definitely I fully agree with you that there are some stringent requirements for the turbine piping and as well as compressor piping with respect to the pipe support, stress analysis and loads and everything that needs to be complied actually, but you will be coordinating with the respective stress engineer in order to get it done. So your intention is to see the nozzle of the compressors and turbines, the nozzle orientations, and how to plan the routing accordingly, so you don't have to be fearful about any major equipments. See, look at over here. So here there is a boiler drum from which the steam enters into the turbine, and then the turbine generates the power, and then it goes to the reheat actually. So the turbines are majorly used to generate the power using different streams. Now here this shows the steam. There are other turbines also that uses a gas and everything. Fine. So this is the simple understanding of the turbine. So here there is no complications in the turbine. It's simple one inlet and one outlet. That's it. Now let's go to the furnace. Furnace is also considered to be one of the major equipments. But here the size of the furnace is huge compared to any other equipments. I can approximately say that there will be the furnace which has a height of nearly around 15 meter, the height length, and the width will be somewhere around 20 meters. So that is the kind of the size of the furnaces. Furnaces are basically used in order to heat the fluid that goes to any major distillation columns or any columns. So this is how it looks like. See, you have a furnace, and the furnace will have a lot of tubes over here, and your hydrocarbons will be passed through these tubes, and the furnace will have the fire which is originated from the burners, and this will increase the temperature of this liquid, and then these liquids will go to the columns, and from where the multiple distillations will be done. So however, looking at the furnace, what you have to understand, this is not a simple equipment. This is the most complicated equipment which has a huge number of lines and huge number of materials, because you look at the sizes actually. This includes blowers. It's basically a package generally designed by a particular vendor. Generally the design engineers works in oil and gas. They used to review the vendor package, and and provide the comments based on their previous experiences. So this comes as an package from vendor, but ultimately as a piping design engineer, our intention is to find the nozzles of this furnaces from where the inlet and outlets are being connected. So this is far more important actually. And also when you review the vendor package, you will have to see whether the vendors are complying with all the piping requirements, internal properly supports are provided, the proper right materials and right thicknesses of pipe thickness are used and everything. Those things can be ensured basically. So this is the the conceptual understanding of the furnace. Then what about heaters? See, the furnace are a type of a heater, but there is something known as heater as well. There are two different types of heater we can see. One is a fired heater and other one is the electrical heater. So the difference of these two heaters are only the means of the source of fire basically over here. Here it is by a fuel gas or by any means of fuel, but here in electrical heater it will be through the electrical resources. So why it is used is as I said, the furnace are a huge, but in order to use a particular equipment for a smaller purpose, then the fired heaters are used. The fired heaters are available in different sizes based on the capacity, so that it can be fixed in any smallest area based on the size and requirements actually. So in case if the plant doesn't require a fired heater, because fired heater requires the fuel gas or certain fuels, right? So if there is no source for the fuel gas, they will be going for the electrical heaters. So that's the purpose of the heater. But however, the heater does the same function of the furnace. It heats the hydrocarbon, which will be conveyed or transferred to the another source of equipments where the high temperature is required. Okay. Now let's go to the column. Columns, we have multiple columns, like distillation columns are a part of all process plants. There are various distillation columns are available. One of the most important distillation column is the crude distillation column, or you can say crackers, or there are multiple distillation columns are there. But the intention over here, what is distillation column? It's a pressure vessel. It will have a different trays over here, and these trays will have nozzles connected from outside. Piping will be connecting these nozzles actually, and the hydrocarbons will be filled over here, and based on the temperature differences, the columns will separate the different hydrocarbons, and those will be extracted out also. So there will be an inlet to the column, there will be an outlet to the column, that will be defined in your P&ID. See, and most important thing you have to understand is that the columns internals are also you should have a conceptual understanding, because these are not emptied columns. These will have a trade items, and there are some demisters will be available. There are some filter materials available. There are different types of trays. You can look at these trays over here. Distribution pipings will be available. So when you see a column, the column is not emptied inside. When you see a column, you should have, the column has different trays. The column has a different distribution inside. The columns will have a demister or filtering material, because there are cases that requires filter. So when the fluid passes from the bottom to top, actually it gets filtered, it gets leveled based on the different temperatures. There will be a lot of steam lines, or there will be cold lines. The gas will be taken out from the top actually. So all these things happens. But conceptually, when you look at the columns, you should know that there are nozzles, very important, which are connected to the internals actually. That is the most important thing the piping design engineers lacking, because they don't understand the internals of the columns. So the whatever nozzle that you're connecting, it will have a connection with the inside distribution piping, and the man weights needs to be properly oriented. So the man weights are used for doing the maintenance of the internal trays actually. It needs to be properly sized and maintained actually. So all these things are vitally important for any columns basically. Look at the columns, the P&ID. This is not a P&ID, we can consider as a PFD actually, where it shows the multiple different trays, and you have a feed, which is the inlet, and there are two sections, the stripping sections and rectification sections. From here the condensed gas is taken out, and it condensed, and it goes to the reflux drum we have seen in the previous slides actually. And for the services that needs to be reheated, that is brought out from the bottom of the equipment, bottom of the column, and reheated in the reboiler, and then sent back to the column, so that the column will have the what you call sustained temperatures. So all these things are happening in the columns. So if you have this much of an understanding, you will be able to support in many requirements in your piping design projects during different stages of the projects. Now let's go to the reactors. Reactors are one of the key equipments. See, reactors are also a pressure vessel, but the requirement is that here reactor does a lot of reactions, the chemical reactions actually. So this is how it will typically look like in both photos and as well as sections. Generally in reactors, when the hydrocarbons are passed, and it will have a catalyst inside. These catalysts are placed from outside actually. It will have a reaction so that the necessary process achievements can be done. I mean, the chemical reactions can be done, and the whatever left out catalyst will be taken out from the reactors. So one of the most important thing about the reactors is the reactors are high temperatures. The materials used in reactors will be the sophisticated materials. So it's necessary to locate the reactor as close to any other major equipments which are connected to each other with the reactors actually. So this is the purpose of the reactor. So what you have to understand is that the reactor will have an inlet nozzle. You can look at the inlet nozzle. It will have the maintenance access. It needs an accessibility for placing the catalyst inside actually, and it will have a drain, what do you call, the bottom outlet and the drain outlet, and the catalyst dropout nozzle as well. Fine. So this is how the reactor looks like. You can see different types of reactors which are primarily made by the Indian companies, and there are foreign companies as also. But typically the reactor will look like this, but there are some sizes varies and shapes varies with respect to the different vendors. But functionally the reactor does the same function what I have explained a bit before. Fine. Now let's go to the separators. Separators are primarily one of the very important equipment that is used in the oil and gas. Let me tell you the primary function of the separator. The separator separates the water and oil and gases. Basically, when you receive an oil into the separator, it gets settled. The water gets settled because of the density, and it will be taken out. And the oil gets moved to the next chamber, and from where it is also taken out, and the gas which will be taken out from the vent, the gas outlets actually. This is how it looks like, and this is how an outside it looks like. So functionally what you have to understand, you have an inlet, you have a gas outlet, you have a liquid outlet, but here there are two liquid outlets are there, and you have the PSV. And definitely from the previous slides and all, you will be able to understand that every equipment will have a level transmitter, PG, PT, those will be a part of it actually. Look at over here actually, how the pipings are connected, how the manways are located, how the PSVs are located. So this is typically same. So here the PSVs are like this, here the PSVs are like this. So if you have this much of understanding, it's easy for you to presume your design and understand the magnitude of your design actually. So you can see over here how the typical the schematics are defined in a different way over here. So now let's go to the boilers. See, boilers are considered to be a huge package because the boilers has a multiple activity. I'll tell you. See, for an example, if you consider a boiler, it needs to be what boiler does. Boiler does is it heats the water. The water vapor goes to the steam header, and from there it gets distributed to the different equipments, and then finally it becomes condensate and pumps back to the boiler. So the boiler, it varies with respect to the size of the scope, size of the capacities, and because it will have a blower, it will have a chimney, there are many things are involved. So the boiler package is basically based on the capacity that is required. So when you have a boiler, the first thing is that you need to have a huge size in your mind, and you need to see the prior references of the vendors which have supplied, and what are the similar drawings that are already available in the drawings. So that will give you an idea about what kind of boiler that you're going to deal with. So generally this is how the boilers looks like. It will be a huge package actually, which will have a combination of pumps, equipments, and chimneys and blowers and everything. Filters. Filters are an equipment used in hydrocarbon services to do the filtrations basically. So there are different types of filters are there. There are dual filters, there are single filters. The filter sizes varies with respect to the sizes actually. But functionally, if you look at the filters, this is how it looks like. It will have an inlet, it will have an outlet. Okay, so the whatever items that are inside, it's going to filter it out. Actually, there are filters that comes with the supports. There are skirt supports, there are leg supports, there are different types of supports are also available actually. So there will be different size of a nozzles, the different size of the orientation of the nozzles, level gauges, and those things actually. But technically the intention of the filter is to do a filtration in the hydrocarbon which are planned and designed by the process teams actually. These are dual filters which will does the much higher filtration compared to the other filters. These are all chosen by a respective process engineer. The importance of the mechanical or the piping design engineer is to choose the right filter based on the process conditions actually. So this is how the filter works. If you look at the filter, it will have an inlet and outlet. So the inlet goes in, it gets filtered, and the filtered material, it goes out. This is another types of a filter where it gets the inlet goes in and the outlet comes out from the drain, or either the gas, if it is so, it will pass out from the vent. So these are the typical filtration equipments which are generally used. Maybe the size varies actually here and there, but when you think about the filter, immediately you should have this understanding about how the filter is going to be look like. Either it will have this size, or it will be thinner, or it will be a bigger. So this is how you have to presume your design. So accordingly, based on the size and your understanding of the scopes, you will be able to visualize your design. Now let's go to the next one, flare. Flare are considered to be the most important equipment or important package in any process field actually. This will have a combination of this equipment. So flare is not a single package, right? So it will have a combination of different items. What are the combination? Generally the flare will have a knockout drum where it collects the liquid from the all relief headers and all relief lines. You can see over here. And from here, the gases will be passed on to the makeup water tank, from where some of the waste materials like the solid particles are removed by immersing the gases into the water, and the pure gases will be traveled back to the flare tip. At the flare tip, it will be burnt by using the gases and pellets flames which are supplied from outside. You can see the air fuel gases are supplied to the flare. So what I want you to understand is, see, when you see a flare, you should have three equipments in your main. One is the drum, and another one is the makeup water drum, and you have the flare in your mind. The flare should have fuel gas supply and the flame supply. So these are the two things that supports the flame ignition and flame initiation, we can say. So the gases that travels from the knockout drum to the makeup water and then immersed in water, and then it flows to the flare tip, will be burnt. So when you come to know about any flare package in your project, you should have a space for all of things. You should fundamentally should have a thought process about where to place a knockout drum, where to place a makeup drum, where to place a flare stack, and all these things actually. So that is how you should have to think actually. So and the next one is blowers. Blowers are also one of the very important, but generally in blowers are used for the powder services or services which needs the more air. For example, in blowers are used, and for even flares, the blowers are used because to pump the gases from the bottom of the flare to the tip of the flare. And there are different equipments where the blowers are also used. So functionally, the blower looks like this. It will have a motor and as well as the blower body that will blow the air, and it will have a duct actually. So those duct will carry the air to the certain areas where it needs to be transferred. So this is the picture of this blower, and this is how the blower looks like, and maybe it varies with respect to the sizes. You can see over here there are three different sizes are available. Not available, three different sizes are shown over here. Likewise, there are small size, there are bigger sizes, there are much bigger sizes. So there are combination of packages where the blower and blower is attached with some other equipments as well. So all these things are combination, but functionally you need to have an understanding about this. This is how the blowers looks like. This is how the major parts of the blowers. It will have a and what you call nozzle outlet. It will have a motor, and it will have the connectivity with the motor, and this is how the entire things appears to be and sized actually. So all these things should have an you should have an understanding about it in your mind, like a preconception, so that you can comfortably visualize your design without any doubts. I hope this video has helped you to understand about the different types of major equipments we are generally using in the oil and gas projects. I will meet you in another fantastic video. Until then, bye from Subhash Chandran.